the next thing we'll do is rationalize the denominator. So rationalizing the denominator means eliminating any radicals in the denominator. A really long time ago, the mathematicians all decided that the radicals should not be left in the denominator because you can't divide by something that's irrational. So what they did is they came up with a method that takes the radical and puts it in the numerator instead of the denominator, and therefore they accepted irrational numbers into the number system. Anyways, we're still using this antiquated rule that we're not allowed to have radicals in the denominator, so the following radicals are not considered as reduced yet because there's a radical in the denominator. So right here we have a radical on root 3 in the denominator, and here we have a root 2y in the denominator. And this one, you may be like, wait a minute, there's no radical in the denominator. But sure there is, because the cube root of a fraction is just the cube root of the top over the cube root of the bottom, and therefore we do still have a radical in the bottom. So we, as the simplifiers, need to eliminate the radicals off the denominator. So to do that, you need to follow these steps. Step 1. Reduce the fraction if possible. If we can reduce it, it will come out a whole lot more simple than having to do the rest of the steps. And even if it doesn't come out whole, reducing will always make everything more simple. Step 2. Write the prime factors of the radicands of the denominators. And then we are going to multiply both the numerator and the denominator by needed values to make the number of groups so that all of the terms can go out of the radical, making them have no radical left in the denominator. Then we'll simplify and be sure that there is no radical left, and then lastly, simplify the numerator and reduce again if necessary. Now, all of these steps seem like kind of overwhelming right now, so let's go through some problems going through each step. Step 1, reduce the radical. Well, in the numerator I have a 2, which is not in the radical, and in the denominator I have a root 3, which is inside the radical. So anything outside the radical and inside the radical can't actually multiply or divide, so there's no reducing to be done here. Step 2, write the prime factors of the radicand of the denominator. So inside this radical we have a 3. If 3 was a composite number, meaning I could break it up into prime factors, I would do that. But 3 is already prime, so yay. So step 2 is already done. Now step 3, multiply the numerator and the denominator by needed values to make groups so that all terms can go out. Okay, so we are going to multiply by something, and we know it's going to be a radical of some sort. But we have to decide what's in this radical. I would like my denominator to have groups of 2, because there's a square root, so that all of the radicand values can go out of the radical. So I have a 3 in my original problem. I would prefer to have 2 3's. And the reason I would prefer to have 2 3's is so that I have a group of 2 and that they can go out of the house and I just write them once. So I have 1 3. I would prefer to have 2 3's in the green. So what do I have to multiply in red to make that 1 3 turn into 2 3's? Well, I need an extra copy of 3. So when I multiply, I have 2 copies of 3 and then it comes out. But if you multiply a value in the denominator, you have to also multiply the value in the numerator. So I have to go back and simplify the numerator. This is the last step. So I have 2 times root 3. Because the 2 is on the outside and the 3 is on the inside, they don't actually reduce at all. And I'm left with 2 square roots of 3 over 3. On the next problem, step 1 says to reduce the fraction if at all possible. Now because 50 and 32 are both underneath a square root, I could just write them as one fraction under the radical, and then I could reduce this. Now 50 over 32 both have a common factor of 2, so if I reduce this I get 25 sixteenths. And 25 sixteenths, look at those perfect squares. If I break them back up again, just by doing the first step, reduce the fraction, I don't have to do any of the other steps because the square root of 25 is plain 5 and the square root of 16 is plain 4. So after step 1, I'm actually done. I don't actually have any radicals left in the denominator. So doing step 1, if at all possible, is very helpful here. Okay, on the next problem, 3 over the square root of 2y. Step 1, can I reduce anything? No, I can't. Step 2, write the prime factors of the radicand of the denominator. So we have 2 times y, but 2 and y are both prime and can't break down anymore, so step 2 is done. Step 3 says multiply the numerator and the denominator by needed values. So I'm going to go ahead and write that, so that we have the correct number of groups in my denominator. So I am still looking at square roots, so I need groups of 2. I have a 2, I would like 2 2's. So because I want 2 2's, I need an extra copy of a 2. Alright, let's deal with the y. I have 1 y, and because I have a square root, I need 2 copies of y. How many more copies do I need in the red? Well, 1 more. So that was step 3. Step 4 says simplify the denominator. So I have a group of 2 here, he goes out, and a group of 2 here, and that goes out. So my denominator is just 2y. Yay, there's no radical left. And that's what step 4 says. Make sure that there's no radical left. If there still is a radical left, you probably didn't pick your red correctly. On the last step, it says simplify the numerator. Because I multiplied root 2y in the denominator, I have to also do it to the numerator. Now the 3 is outside of the radical, and the 2y is inside the radical, so because they are not in the same place, they can't actually multiply or talk to each other. So think of the 3 as like outside of your house, and the 2y clearly is inside the house. If you're outside and your friend is inside, can you talk to them? Well, no, you either both have to be inside the house and then you can multiply and talk to each other, or if you're both on the outside, well then you could talk to each other, or in this case multiply. So the fact that you can't means you're just going to write them together. Now 2 and 3y, which are both outside the radical, right? If that could reduce, then you would reduce, but it can't, so I am done. So on the next problem, step 1 says to reduce if at all possible. And I can see that 5x and 20x squared have common factors. So let's see if we can't reduce that and make this a whole lot easier on ourselves. So I wrote it as one big fraction. 5 over 20 reduces to 1/4, and x over x squared reduces just to x. So when I split this back up, I'm getting root 1 over root 4x. Now I know what the square root of 1 is, that's just 1. And I know what the square root of 4 is, that's 2, but unfortunately the x is still under the radical. So yes, reducing did help, but I still have to do some more. Step 2 says write out the prime factors of the radical. Well, in this case it's just the square root of x, which can't be factored anymore. So I am going to multiply by some radical, so that in the radical I have all of groups of 2, because we're still square root here, so we're still looking for groups of 2. I know I have an x, but I need 2 of them so that they can go out of the house. So I have 1x in red, and I would like 2 x's in green. So what I would like to do here is multiply by 1 extra copy in the orange color. Now it's clear to see that in the denominator, the 2 was already out, but the 2 pairs of x's inside the radical can come out and just be x. Now I have the denominator with no radicals, so let's go back and finish up the numerator. 1 times root x is root x, and nothing else can reduce, so I have root x over 2x. Yay, I know that I'm reduced because I don't have any radicals left in the denominator. On our next problem, let's break this up into 2. There's nothing that can be reduced here at all. So let's see, I have the square root of 1, which is 1. In the denominator, I have a 12x cubed. Well, 12 can be broken down. Okay, it looks like I have 2 2's, a 3, and then 3 x's. I would like to multiply that by some value in the numerator and the denominator so that I make a new radical with only groups of 2 in it. Okay, so let's go back through and look. I have two 2's. Well, two 2's, that's perfect, right? So I'm going to keep those 2 times 2 right there. I have just one 3. Uh-oh. I need two 3's, don't I? Which means I need to add an extra set of 3 under my multiplier, under the radical that I will multiply. In x's, I have 3 x's, but I need groups of 2, so 2 is good, but I need 2 more to make 4. So I had 3, I need 4, so that means I need an extra copy of x. Whatever we multiply the denominator, you also have to do the numerator. And before I get too far in this, let's just make sure that all of this comes out nicely. Oh, a group of 2, yep, that goes out. This group of 2, that goes out. This group of x, that one goes out. And this group of 2 goes out and becomes one more x. And that looks like I have no radicals left in my denominator, so that's good. Let's go back and finish my numerator. 1 times the square root of 3x is the square root of 3x. So my final answer is the square root of 3x over 2 times 3 is 6. X times x is x squared. And this is reduced. There's nothing else I can reduce, so I am done. On the next problem, 49x cubed and 9y cubed don't have any common factors, so I can't do any reducing. Step 2 says to factor out your denominators. So 9 is 3 times 3. Y cubed is 3y's. I would like to multiply that by some value so that my denominator only has groups of, in this case, 2 because it's a square root. So let's go back. I have 2 3's. Yep, that's a group of 2. I have 2 y's. That's a group of 2. Uh-oh, I have one more y left, which means he needs an extra copy of y. So I need to multiply by y in the numerator and the denominator. So we had the numerator 49x cubed times y, which is going to be the square root of 49x cubed y. Clearly we're going to have to reduce that. We'll do that in a minute. It looks like this 3 in the denominator, the y in the denominator, and the y in the denominator all have groups of 2, which shouldn't surprise you. This is exactly how we worked it out. We chose this. So the 3 comes out, the y comes out, and another y comes out, and which gets me 3y squared. I do need to take a minute to work on the numerator, which is 49, 7 times 7, okay, x cubed y. So I have a group of 2 and another group of 2, so that's 7x on the outside of your house, and then another xy left on the inside. Now, if anything can reduce on the outside, like if the 7x and the 3y squared could reduce, you would do that. But in this case, they don't, so we are done.